Now, let's go over basic three-point lighting in 3ds Max. Per usual, we'll cover just the fundamentals of very basic lighting, and we won't touch on more advanced lighting techniques. But as always, you're welcome and encouraged to read about any aspect of lighting in the software help docs, and to experiment with any lighting features that you would like to try out. The reason that it's so important to be able to set up three-point lighting is because virtually every shot you've watched on television or on film, and the vast majority of professional still photography you've seen, has been lit with some variation of three-point lighting. Three-point lighting consists of three light sources: a key, a fill, and a backlight. Although in some instances, more than one light might be used for each constituent of the three-point lighting scheme, we'll stick with just one light source for each. The key is the main source of illumination and produces the illuminated area on one side of the subject facing the camera. Typically that's the front of the subject, whether that's a person or a model, but there are times when you would set the camera to look at the side or the back of the model. So it's whatever side is facing the camera. The key light is also the light that's responsible for the shadow that the subject casts or the model casts onto the ground or onto a backdrop. The fill light lightens the darkened areas produced by the key light on the other side of the model of the side facing the camera. And the backlight shines on the back of the subject or the side opposite the camera and is used to separate the subject from the background or the foreground from the background. The backlight must be intense enough to produce a rim of light or a halo of light around the back perimeter of the subject or the model that can be seen from the front or the side on which the camera is placed. The location, angle, intensity, color, temperature, and the shape of the lights can vary wildly in different three-point lighting setups. And in real-world photography and cinematography, the lights can be both natural and or artificial. But you'll use some permutation of key, back, and fill lighting for the majority of shots that you render in 3D. There are numerous lighting and shadowing techniques available using both direct and indirect light sources, from high dynamic range imaging or HDRI, in which special photographs with extra information within the bright and dark areas of the composition are used to produce the lighting itself, to global illumination, which refers to a range of techniques that simulate the way light interacts with and bounces off surfaces, to ambient occlusion, which simulates the soft shadowing that is achieved from indirect light sources. But we're going to stick with just direct lighting only. We'll use strictly spotlights because they allow you to easily control the direction and spread of the illumination. And we'll cover only two techniques for creating shadows: ray traced shadows and shadows that are produced with texture maps. So the first thing you want to do is to create a backdrop and a ground surface so that there is something other than a black void around your model or models, because you need a backdrop of some kind in order for the rim or halo of light from the backlighting to be able to separate the subject or the foreground from the background. And then you need a ground surface onto which the shadow cast from the subject by that key light can be seen. So I'll just create a simple box, scale it to fit around my model, convert it to an editable poly, and then get rid of the top and front polygons so that the camera isn't blocked. And as we discussed, polygons have two sides, and by default it's the outside of the polygons that are the front of those polygons. So I'll select all the polygons remaining on the box and flip the normals by clicking flip. And I'll just drag a basic shader to the box and use a very light gray color for it. And typically you'll create the key light first. So I'll create my key light first by going to Create, Lights, Standard Lights, and then Target Spotlight. And this will create a direct spotlight with a target to aim that light. So I'll move the target to the center of the model, move the light to one side of the front of the model, and above it somewhere around 45 degrees, but it's up to you where you place and how you angle the lights and which side the key or fill is on in relation to your model. Now I want to see the lights I create and the shadows produced by that lights in my viewport. So I need to set the viewport to illuminate with the scene lights and display shadows under its user-defined menu. And even though you can see the lighting and shadows now, you always want to render to see what the actual lighting and shadows look like, because it will differ from what you see in the viewport. And I'll turn on shadows for this key light, and we'll go over in a bit the two shadowing techniques we'll touch upon. And again, we're only going to cover the basics of these direct lights, but as you'll be able to see, there are a lot of settings you can read about and experiment with. And I'll adjust the intensity of this key light. I could also change the color as well by clicking on the color swatch. You use the hotspot and fall-off spinners to increase or decrease the size of the brightest region of the light and the degree to which it softens around that region. So the smaller the hotspot and the larger the fall-off around it, the softer the gradation around that hotspot. I can change the color of the shadow so that it's not quite so black. I'll use a dark gray. And then the density so that it's not so opaque. Attenuation is how much the light diminishes in intensity from the light to the subject, which can vary with different types of real-world light sources, so you can play around with that to your liking. The far attenuation value sets the distance at which the light drops off to zero. The near attenuation value sets the distance at which the light fades in. When you check Use for far attenuation, the light at its source uses the values specified by its color and multiplier values. It remains at this value from the source to the distance specified by the start attenuation. Then its value drops off to zero at the distance specified by the end attenuation. You can see the start and end location by turning on the show parameters, which appear as these blue circles that you can see here. And you can experiment with attenuation for some or all of your lights. But again, it's your decision what you want your lighting to look like. And as long as each light source, the key, the back, and the fill, does their respective jobs in the three-point lighting scheme, that's really what matters at this point for you. And I'll just leave these off, and I'll use just decay. Now, decay also allows you to adjust the light's intensity over distance. The none setting causes the light to maintain its full illumination forever, or until the far attenuation distance you set. Inverse causes the light to decay using a specific formula that relates to the attenuation values. Inverse square causes stronger decay by squaring the decay set by using inverse. Now this setting is closest to the way that real world lights decay, so I'll use inverse square, and I'll set the aspect ratio in my render setup to something manageable like 320 by 240. You don't want to render really high resolution images as you're testing your lighting because that's just wasted time. So you'll want to use something small like 320 by 240. So once I like how the key light is working, I'll simply copy it to create the fill light. Then I'll move it over to the other side to hit the darken areas opposite the key. Now, and this is very important, in real-world photography and cinematography, great pains are taken to avoid what are called double shadows, because in the real world, every light source will produce shadows, and seeing double or multiple shadows cast from a single subject is considered poor or amateurish lighting. In real-world photography and cinematography, light sources have to be blocked in various ways to avoid seeing those double shadows, because there's no way around that in real-world lighting. Luckily, in 3D software, you can simply turn off shadow casting for any light you want, which is a really big plus. So I'll turn off shadows for the fill and take its intensity way down, adjust the position, render that. Okay, and that looks pretty good. So now I'll copy the fill light to get the backlight, and I'll move it to the back of the model, and I'll take its intensity way up because I need it to be bright enough to create that rim of light or that halo of light around the back perimeter of the model that can be seen from the front. And I like to aim the backlight up so that its intensity beam doesn't hit the ground plane, because it's often a very bright light and it can be distracting. It can interfere with the shadow cast from the key light. So for shadows, you can use the shadow map setting, which is the default, which will create shadows using texture images. And then below here, under the shadow map parameters, the size value is the aspect ratio used for that texture. The smaller the texture, the more pixelated the shadows will be. The larger the texture, the smoother the shadows will be, but larger sizes will increase render times. Or you can use ray trace shadows, which will produce very crisp, accurate shadows by calculating the path of rays from the light source, but ray trace shadows take longer to render. So this looks pretty good, I think. But experiment with your three-point lighting until you get a result that you like. Use different light color combinations, different light locations, angles, different intensities, decay settings, attenuations. Again, you can't break anything here. And while different light and shadow settings will impact your render times, and that's why you should always test how long a single frame takes to render before setting off the render of an image sequence, please feel free to experiment with these light and shadow settings as much as you want until you get a result that you feel complements your modeling texturing work. This is your first time working with 3D lighting, so the main goal here is to start to understand how 3D lighting works, how shadows work, how different settings impact render times and the quality of the image, how different light colors interact with the colors that you've used for your model and textures. But try to have fun with it because you're getting a chance to light these shots in a much faster and more nimble way than you would if you were setting up a real-world three-point lighting setup.